Yeah, Kapil. Okay, yeah, sure. I would do that. Yeah, Kapil. Okay, yeah, sure. I would do that. Yeah.
Hi. Okay. Thank you. Thanks all. Hey, thanks for joining the session, guys. It's been a really tough time, but still we like to be in connect, particularly on the technical streams. Thanks for all of your time. Quickly, I'd like to touch upon what are we doing in the containers and how Pradeep is contributing, for the transforming our entire infra into container based. So we are managing an application called Team India. So that's a internet facing application, and as well as which is having it in both yellow zone as well as in green zone. So Pradeep was driving this entire effort where building the containers and deploying it in both the zones and making sure that it's highly available, because right, when it is comes to internet, we need to make sure that the availability is key impacted. So he is making sure that as it's being driving with without any downtime, and we also make sure that as the response time is very important when it's going to be in internet facing. So both is able to manage it with our current containers, and we have multiple microservices, and we convert all those microservices in the containers, and we deploy it in Kubernetes. So Pradeep is one of our key contributor, and he's an architect who's consistently working for a long time on the infra side, and it's really important to touch upon the developers angle when it comes to the containers. I think Pradeep is going to give a good insight to all of you. It will be really good session, and it will be more informative too. So keep your ears open. And with that note, I'll hand it over to Pradeep. Pradeep, it's all yours. All the best.
Yep. Thank you, Shiva, for your good words. So good evening, all. So, just a quick confirmation. So everyone is able to hear me, and my voice is audible, clear.
Yeah, Pradeep, you are loud and clear. Yes.
Okay. Yep. Thank you, Shiva. Thank you, Kapil. All right. So, first thing first. So, I would like to say a disclaimer that whatever tools we are going to see and whatever stuff we are going to deal here for the next 1.5 hours, it's no way related with Verizon and its affiliated branch. So that is one thing I want to let everyone know priorly. And moving on, so okay, a quick intro about myself. So I won't take much time. So my name is Pradeep Selvaraj, and I have around 10 plus years of experience in IT industry. And with Verizon, I am working for past 5 years. So that's a quick intro about myself. So fundamentally, I am a person who is part of Linux administration. So that's where I started my career. And apart from that, I earned other certifications, which you could find it in the LinkedIn profile. So I would be very proud to say I'm a Linux system admin. So that's the qualification, and that's a start of journey in the IT industry for me. So all right, so let's get on to today's thing. So uh, we are going to see primarily how containers are would be leveraged by the developers. So you know, Docker, containers, Kubernetes, so everything has been the buzzword in the IT industry for past some years. So how many of you know? I'm not sure, but some might be using containers, or some might be leveraging Kubernetes, or so I'm not sure about how much people are there. So if it is a live session kind of a thing, I would be able to ask. We can have a live interaction, but since it's a virtual, I would ensure that I will try to touch base the fundamentals, and I will try to walk you through how we could empower the developers using these technologies. All right. So containers, Dockers, Kubernetes. So this tool sets has been growing tremendously in the past years. So there is a metrics that was published recently. So you could see it in the internet itself. So there is a 173% hike in the job opportunities if you learn Docker containers and Kubernetes orchestration. So this is the uh, uh, trend that is right now going in the market. So it was there were time 2 to 3 years back when DevOps came, and agile models came, and Kubernetes Docker adoption started, and every company wanted to adopt it because it's the latest technology and it gives a lot of features. So every company wants to adopt it. So that's when they started looking out for people who's very good in that. So primarily, if I would say the Docker, a container, a Kubernetes, or whatever it is, so the first thing that comes into everybody's mind is, okay, this is not related to us. So I am a developer. I do Java coding. I do Node.js coding. I build static websites or dynamic websites. So it's no way related to me. I just type in the ID and I push the code, and it is up to the operation engineers and the other people to take care of it. So that was the mindset uh, for the developers till this DevOps came into picture. So primarily, you need to know what is this DevOps. So if someone, maybe you can voice it out. Uh, can someone let me know what is a DevOps? As a simple thing. So we'll just have it as an interactive. So I'll go ahead with the intro of the containers, other thing. Then we'll get into how it can empower the developers. So can someone say what is the DevOps, and how it changed the culture, or how it changed the things among the developers and operation people? So anyone? Or if not, you can put it in the chat also. It's not a problem. Okay, so all right, so fine. Let me tell you what DevOps is. So priorly before DevOps came, so let's take 5 years before. So we were having developers working in one place, operation people working in some place, and you have some release engineer, build engineer, DB admin, so on. So a lot of people were there in an IT industry. So developers primarily does the coding, push the code into the version control tooling like Git, GitHub, or whatever your company uses. So someone would take that code, build it, deploy it in the server. So this is what exactly happens. So when the developer pushes the code, and when the operation person deploys the code into the server, so they were kind of out of sync. So someone has to call up a person, operation person, and say, hey, okay, I have done with my coding. So everything is good. So go ahead and deploy it to the production. And the ops person would say that, okay, today I will not be able to do it. So tomorrow I would do it. So there was a very big gap between the developers and operation people. So everyone was thinking how to bridge this gap, how to bring both of them together. So that's when the DevOps came into picture. So what DevOps actually is, it is a culture. It's a cultural change that came into the IT industry. So when you see whatever I said right now, the developer being an isolated entity and an being an isolated entity, it just bridged the gap between the both. So right now, when I say DevOps, it is a cultural philosophy that was incorporated into our organizations. So what is the advantage of the DevOps? So primarily, if you see what is the advantage of DevOps, the delivery of the code or the delivery of your application and the service to the end customer has been tremendously increased. Or we can say that the delivery at which we are doing is uh, like we don't have any dependencies and all. We are delivering the application to the end customer with the high velocity. So high velocity is the term they actually use in the DevOps world. So how much quickly the developer fixes the issue, how much quickly it reaches the developers, the end customers. So we have to shut the mouth of the customer if there is something like a bug or something in the application. So how quickly we are going to figure it out, how quickly we are going to deliver it to the customer is what DevOps is. It's a cultural change. So in the DevOps world, everyone is part of the life cycle of the application. So there is no separate entity called ops, there is no separate entity called dev. Everyone is together and everyone is considered as a single entity in the application development of DevOps. So this is the basic intro about the DevOps culture and so how it has been adopted in the organization. So after DevOps came, uh, companies started adopting that culture. So they streamlined their hierarchies, they streamlined their organizations to meet this DevOps. They brought in agile cultures to ensure that DevOps is in the place. So when DevOps came into picture, so the automation of doing the process. So like I build a code, I'm pushing it to Git. So a build should happen. Someone should not come and do the build when I push the code. So that's an automation that they have to do. So those kind of automations has been streamlined in the DevOps process. So we call them as continuous integration, continuous delivery, and continuous deployment. Or sometimes we call it as CI and CD. So that's what the name they commonly give uh, uh, to the DevOps thing. So whenever we interview folks, so tell me something about DevOps. So the first thing they would say is, I do CI/CD. I know about Jenkins. I know version controlling Git, something like that. So that's how they say it. Actually, you need to understand what is a CI and how it fits into DevOps world. You need to know what is continuous delivery, how it fits into the DevOps world, again the continuous deployment. So CD, when we say CI and CD, the CD has two things: continuous delivery and continuous deployment. So most of the people might not be knowing what is the exact difference between both. So I would be clear. I would be ensuring that you are clear after this session. So what is a continuous integration? So like I said, you might be having a team with 10 folks. Let's take you have a big development project. You have 10 developers. You have operation engineers. You have release engineers. You have agile scrum masters. You have a lot of people in the place: managers, tech lead, dev lead. You have a lot of things in your organization. So now the 10 developers, so they would be individually doing the coding. So they would be merging their code for a release. So how good the code would be? So how would you certify the code that developer has brought up or they have built is meeting the quality standards? So the CI, the continuous integration piece of DevOps, is going to ensure that the code that they have built meets the standards. Means you are going to do a code scan for any vulnerabilities. You are going to do a code analysis if it is it meets the standards of your organization. So you're going to do all the scans in the continuous integration process. At the end of continuous integration process, what is the output you're going to get is the build artifact. So you are a Java developer, you push the code, it's going to scan with code analysis and vulnerability analysis. At the end of the CI pipeline, you will be getting a jar, which is a build version of your application. So that jar is the end of CI. And that is a jar that would be promoted to your production environment. So this part becomes automated. So this testing and your code analysis and building, everything becomes part of your CI pipeline. So this is what continuous integration is. And the next piece is continuous delivery. So continuous delivery is nothing but you get this artifact or the jar from the output of CI. So you need to promote that to some environment. It can be a staging or a testing or preview environment, or it can be a production. So you need to move it to a higher environment from the dev. So you can do that in an automated way until a pre-prod, but from pre-prod to production. So you might have a lot of environment. You have UAT, you have testing, you have a lot of environments. So pre-prod is considered as anything that is before production. So until pre-prod, everything happens through continuous delivery. And from the pre-prod to production, there is a manual intervention that should happen. So that's a primary difference between continuous delivery and the deployment. So in the continuous delivery, there is a click of button that should happen. Someone has to take the authority or the responsibility. Okay, I have certified this code. I am certifying this bug fix. I am certifying this break fix. I am taking the ownership. I am permitting this to go into production. Someone has to take the ownership. They have to click the button. If that kind of pipeline happens, it is called continuous delivery. If you trust the developers, or if you trust the process that you have built in the DevOps, like the build, testing, pre-prod, everything, and you don't need to take, you don't want someone to take the ownership. So whatever code is built, they can be promoted directly to production. If you have that trust built upon. So companies initially start with continuous delivery, but when they get matured in the DevOps model, they move on to the process called continuous deployment. In the process of deployment, no one is going to take the ownership. The moment the developers commit the code, all the code scan are going to happen. The security scans are going to happen. The build is going to happen. The artifacts are pushed to pre-prod. The preview environment is evaluated or validated, and everything is good. It is automatically pushed to production. So that is the place where every organization is trying to reach, and that is the maturity level of DevOps. So when you want to ask a company, are you DevOps compliant? The first thing that you would ask them is, are you using the process of continuous deployment or continuous delivery? If they say it is a continuous delivery, then still they don't trust their process. If someone says from the company you are reaching out to, they say we have a continuous deployment, we don't even have a touch based deployment. The moment developer commits, everything is in production. So if someone is able to build that, then that is continuous deployment. That is the end of your DevOps process. That means your team is fully compliant with the culture. So that's what the quick intro about DevOps, CI/CD, and other things. So how this thing happens, basically. So you know that this entire process is kicked off from the developer. So developers are the key people in DevOps. So they do the coding. So a lot of people might be there here, like system admins, DB admins. So a lot of people would be there, but the DevOps kicks off from the developer. So they do the coding, they commit it, and the lifecycle starts immediately. So how to empower them? So you have a lot of technologies in the market right now. So the companies are in using legacy hardwares, legacy servers, and they are some people are into the virtual machine world, or some people are into cloud, some people are into containers. So every kind of options are available. So how developers are going to adopt it? So what is the quickest way? So what is the best practices that they have to adopt? So that's what we are going to see it here. Here we are going to primarily see about how to leverage containers, because containers is the technology of next generation. So I would frankly say that containers is going to be the next generation technology for around 10 to 15 years. So you can daringly invest your time to learn that, to invest your opportunity, so that you keep growing in your career. So how to enable this Docker stuff or this container stuff to developers? So developers, they do coding. So what's the relation between a container and those kind of things? No, you can empower them. So we are just making the developers to use the tool sets so that they can provide an environment that is very portable. So when I give an intro about the Docker containers and the Kubernetes, I would let you know what is that. So I'll quickly go ahead with uh, what is Docker, virtual machines, and those kind of things, so that you would be able to understand. So let me unshare the screen. So we are not still into the agenda. So I will quickly try to wrap it up in 5 minutes. So just give me a moment. Open the picture and okay. So here it is. So I want to share this thing. So if you see virtually, you would be able to, if you see graphically, you would be able to see what is the difference, primary difference between I will go ahead with my entire screen. That would be better. Okay, share. Okay, so see it here. So you're able to see here right now. So the continuous delivery. So you can see here there is a manual intervention between your acceptance and deploying to production. This is the delivery process. Deployment, it is done with automated way. So this is the primary difference. Now you can see whatever happens. The code starts in the left, developer commits it. In the right, it goes to production. So this is the entire process of your continuous delivery and the deployment. So any doubts on CI/CD, DevOps, and other things? So we will be moving into the other pieces like containers. So can I have a quick confirmation on that? So you can put it in the chat also. Okay. So there is a question in the chat like without testing, how they're going to promote it to prod. So yes, so you have automated testings in the place. So they would be performing that. Uh, like you said, without testing, moving the code to production is not a best practice. So testing would happen. Those would be integrated as part of your pipeline. And CD test are automated as well, and just kick off automatically as soon as the commit is made to Git. Yeah, right. So that's what the CI/CD pipeline is. So they would be doing a static code analysis at the stage of CI, and they would be doing a dynamic code analysis at the stage of CD. And they can do some automated testing, like they can do a feature testing or they can do functionality testing. So whatever it is, so they can do everything in a testing environment, or we call that as a preview environment. So whatever code you have developed that is ready for production release, so they would be deployed in the preview, and we will ask the stakeholders to evaluate it. So after the evaluation sign off is given, so that would be automatically moved to the pre-prod or user acceptance testing, whatever it is. From there, someone has to take a responsibility if it is a delivery. If you feel like the process is trustworthy, then you can seamlessly move it to production. So that's what it is. Without testing, we are not going to move the code. So that is the first thing in the DevOps. All right. So any other questions on it? All right. So let me get into what is containers and what is its power. So why it is becoming so popular and other kind of thing. So everyone knows that we have been using uh, a normal physical hardware for the data centers and other kind of thing. So we purchase a hardware like mm, a server with CPU, memory, storage, blah blah blah. So we have a lot of things. So we buy that, we store it, and we ask a system admin to configure it, build our application, put everything, configure, and give it to us. So we do the deployment. So that was the legacy trend. So we have been doing it. So if something goes wrong in the server, we have to fix it. So it ends up with a downtime. So after that, we moved into virtualization era. So the VMware was a pioneer in that. So they started bringing virtual VMs, and we were able to quickly build server VMs, and we were able to deploy our application. In case something goes wrong, we were able to quickly restore it back. So that was the era of virtual machines. So I would say from like 2000 to 2010 something. So virtualization was there in the place. So before that, it was fully legacy. So post 2010, so Google came up with something called containers. So if you get into Google technology, if you start learning Google Cloud, a lot of things would come into surprise for you. So Google actually manages everything as a container. So they are not managing as a virtual machine. So why Google is not using virtual machines or physical hardwares as a delivery model for their applications? So you need to understand what is the reason behind it. So let me open a picture and I will explain you on that. So we'll quickly wrap these things. Okay. So this is a picture. So I pulled it from the docker.com. So nothing I have created. So I just pulled it from the internet. So this is a physical hardware that you buy it in your data centers. It can be an infrastructure. We call it as an infrastructure. So it can be a physical server, storage, network. Everything is physical. So whatever isn't physical, it is infrastructure. So VMware came with hypervisors initially. With that hypervisors, you would be able to build a lot of virtual machines. Each virtual machines will act as an application server or a database server or a web server. It can be anything. So it is of your choice. You can build it off anything. So you can see here infrastructure over that we are putting an hypervisor. So hypervisor is basically uh, yeah, yeah, abstraction software. We basically call that as an abstraction software. It's not going to be a heavyweight, so it's not going to be a full-fledged operating system. It's going to be a thin layer over the infrastructure that is going to provide the entire infrastructure to your virtual machines. So within the virtual machines, you are going to have the thick operating system, and over that you are going to put your middleware or your application, and you're going to run your software. Maybe it is. So I'm sorry. Any questions from anyone? Okay. All right. So I see a question in chat. So it's from the YouTube thing. So let me answer that and get back to it. So what about the rollback plans in DevOps? If something goes wrong in production environment, so yes, you need to have a rollback strategy whenever you uh, do a deployment to production environment. So basically, you have a lot of ways like blue-green deployment, or you can go with red black or whatever it is. So blue green deployment is one way by which you can have two versions, or you can do sidecars. So that is another concept that is available in the Kubernetes. So if you do the deployment into Kubernetes, you can have sidecaring. So you can just split the percentage of traffic to your new version and see how it responds to the actual traffic. And based on that, you can just flip all the 100% of traffic to the new version. So that's how you would be able to do it. So DevOps, yes, you need to have a rollback strategy. Without that, the cycle will not be completed because you need to monitor as part of DevOps. So how is the environment reacting? Something you put in the production, if it breaks the entire app, then obviously you need to have a rollback strategy. So that's where you do some kind of smoke testing in the environment to see if all the touch points are working fine. So rollback strategy, again, like stated in the chat, so it is must and part of the DevOps cycle. Okay, so this is the so coming back to the virtual machine. So this is the virtual machine stuff. So the hypervisor basically has a thin operating system, and over that, you in your virtual machine you have a thick operating system. So this is actually a redundant piece. Practically, if you see from a system admin's perspective, maybe a Linux system or a Windows system admin's perspective, so the hypervisor and the guest operating system has kernel as the heart of their operating system. So basically, they do the hardware resource abstractions. Both does the same job. Sat and thought, why I need to have two kernels running for my app? So why can't I have one? And I can just make the app to run independently. So that is the concept which came to containers. So this is what VMware came. So VMware thought, okay, I will give a hypervisor. You put VM over it. Whatever OS you want, Windows, you want to put Solaris, you want to put Linux, whatever you want, you can put it. So that's what VMware thought. So Google saw this. It was a good idea, but Google saw an opportunity. Why to have a redundant kernel? So this hypervisor is going to take some resource. This guest operating system is going to consume resource from the infrastructure. So there is no 100% effective utilization of the hardware because of this redundant hypervisor. So that's where Google thought, okay, I would come up with a new thing. And that's what we call it as a container. So let me show that picture too. Again, it is pulled from the docker.com. So this is what exactly the Docker does. So Docker primarily uses two concepts. So one we call it as C groups, and one we call it as resource grouping, which has come from the world of Linux. So C groups is if you're an Oracle admin, you might be coming across this term C groups. So I'm not going deep into that. It's just an intro about what Dockers and containers. So this is what. So the infrastructure is here. You have an host operating system. It can be anything. If it is a thick operating system, it is a well and good. You can have a full-fledged Linux, full-fledged Mac OS, or you can have Windows, whatever it is. Or you can go ahead with the thin operating systems, like you can go ahead with the Alpine or whatever you want. So over this host operating system, you are going to put a daemon. That daemon is called as a Docker. So what it's going to do is, it's going to make your app run independently within the single operating system. So it's going to logically group, or it is going to isolate your application. So you can see here, app A runs independently. and it talks to Docker daemon, and the Docker daemon talks with the operating system or the host operating system's kernel, and the kernel allocates the resource from the infrastructure. Same way, app B does the same thing to the Docker daemon. Docker daemon talks with the host operating system. It fetches the resource from the infrastructure. Likewise, you can use n number of app containers within a single host instead of having a thick virtual machine and over that putting an app. So instead of that, Google saw this as the opportunity and they have built it. So Google has been using this for over 10 years. So they claim that in one of the conference, they claimed that they have been using the containers for more than 10 years. And after 10 years, they have open sourced the entire container piece and how they are orchestrating it to the open source community. So that's how the containers came. So now we are going to see how this isolated environment. So the app A, app B, app C, they will not know that they are running in the same host. They cannot talk to each other. You can make them to talk to each other by tweaking some networking or doing something in the container level. But when they run as an isolated entity. And what actually you would be doing when you containerize an app, you're going to put all the runtimes, you're going to put your application, everything, you're going to pack it, run it over the Docker daemon. So what's the advantage? You can just lift that container, run it anywhere. So just think, I'm going to switch this operating system from Linux to Windows. What I have to do is I have to just install this Docker daemon and I can run the same app. Think of the situation in the VM world. So I am tied up to VMware hypervisor. Suppose I want to switch over to Zen-based hypervisor, which is Citrix. So I need to reinstall my operating system, or I have to run some utility that can transform my virtual machine built upon VMware to run in as Zen hypervisor. So I need to do the translation. It is not portable. The virtual machines are not portable. But whereas you see the app A, app B here, which is running over the Docker, those are portable. Even if I switch the operating system, I need not rebuild my app. I need not do anything. So this provides portability. The portability is one of the biggest feature that containers gives you. So how the developers build their app in their local and deploy it in their local environment for testing, same app could be run in the production. That's the portability containers would give you. So what is the big thing? So everyone might ask, what is the big thing about it? So to be very frank, if you have worked on the operation side, so because I am a Linux system admin, I have done the deployments. So I know I have faced a lot of issues when I do deployments. So developer would build the code, give it to us. The release engineer would give it to us. We would take that code and deploy it in some environment. Let's take I'm deploying it in UAT for testing. The jar or the app that they give, when I try to run in the UAT, it will not start at all for me. When I come back and say to the developers, hey, whatever code you gave, it is not working in the UAT environment. The developer would obviously say that it is working fine in my local. I have tested 100 times. It is working fine in my local. So it is your issue. Go and fix it in our server. That's what developers would be giving the answer. So what exactly is the missing piece? So when you see into DevOps, streamlining the process, the important stuff of DevOps. So there is a gap that has been coming here. So developer says it works fine in the local, but an ops engineer says that it is breaking in the UAT environment. So what has gone wrong? So when you build an app, there are a lot of dependencies. And there are a lot of environment-dependent parameters. So containers basically pack everything into a single entity. So developers say that I am using X, Y, Z as dependencies. So they would pack it as a container and give it to us. I can lift and shift that container, put it in testing environment, ask the testing person to test it. After testing person gives a sign off, lift that container, run it in UAT, get a sign off from a testing an acceptance testing person. And if that is cleared, I can lift and shift it to a pre-prod environment. And if that is fine, then I can lift and shift it to a production environment. So nowhere I'm not doing any configuration changes or any tweaking in the environment. So portability is one of the biggest advantage this container gives. And that is where the organizations are interested in. So that's where containers become very important. And that's why the opportunity for the containers leveraging that as part of your coding standards has become an important thing in current trend. And it is right now we are in the high time. So basically, if you know when containers came into picture or when containers was rolled out, if you want to know, so in the year 2013, Docker was publicly rolled out. So just for an information, and Kubernetes was open sourced on 2014. So it's right now I think 6 years back. So last year we celebrated 5 years of Kubernetes. So I just presented one of the concepts that I'm going to share you today in the 5 years of Kubernetes demo. Okay. So it's been 6 years. So initially, people adoption was very less, but right now the adoption is very huge. So invest your time so that you would be able to uh, grab your career opportunities. So this is the quick intro about the container application. So how do I, if you want to learn, how do I install Docker? How do I install that? So one place I would advise you to go and learn a lot would be is docker.com. So just go to this place. Okay. So give me a moment. So this is the URL. So mostly, I guess most of you might have been knowing this. So if you are using a Linux system, then you need not go to this site. You can just give yum install if you're in Red Hat based platform, or apt get install Docker. You would be able to get the Docker daemon up and running. And if you're in Windows, there is a catch. So this Docker technology or the container technology is primarily built thinking you use a Linux operating system. So when you want to get your hands dirty in the Docker environment, you need to type commands. So Windows users, you need to stretch a little bit, switch over a little bit to the Linux world, because open source gives you a lot of power through the console. So you need to type a lot of commands here. So for Windows users, Docker.com has come up with a product called Docker Desktop. Just download it and install it in your desktop. So it would do all the bootstrapping for you. Docker daemon would be running for you, and you can do all the stuff, whatever you wanted to do here. So you can learn a lot about the Docker, how the things are. I'm not going to cover or deep dive into it. So we are still not into the topic, what we would like to cover. So with this set, I would move into Kubernetes. With 2 minutes, I will finish off Kubernetes and we'll get into the actual topic that we are going to deal today. So this Docker. So let me get into the console first. Okay, so let me maximize it. Okay, Docker PS. So Docker is the primary command. So the session today would be mostly on practicals. So I've just given an intro about the Docker, but I would let you know what are the command I'm trying to use here and all. So Docker is the command. So you can see here. So Docker info. So this is one thing I wanted to let you know. When you try to install and practice in your laptop, or when you do it in an organization, because a lot of people really don't know this. So I wanted to let you know the one of the thing that Docker actually has. We can say that it is a security issue, or we can say that it is a security concern for the organizations. But just for information, I'm letting you know, have it, don't try to, so just learn it, don't try to misuse it. It is one of the concept that Docker has. So Docker, when you try to install, it installs as a server and a client module. So the command that I ran right now, Docker, it is a client. So there is a Docker engine that is running inside your kernel. Okay, so that is exposed in the port called 2375. And that port is not restricted. It is wide open. If you don't have a firewall, or if you don't have something to stop, or if you are not controlling that port, anyone in the world would be able to connect to your server. The server, when I say the Docker daemon that is running in your local. And the point number 2 is the Docker daemon runs with root privilege. So when I say root, it is the administrative privilege. So I would be able to run, or I would be able to provision a Docker daemon remotely by connecting to your Docker daemon and bind a volume. For example, I could be able to bind a volume called, let's say, For example, let's say I want to bind the internal Docker path. So I'm not going deep into Docker, but I'm just letting you know. So the path, let's take path. This is a path inside container. I am binding that to your slash root something user like XYZ. If I am giving this as an argument in the Docker command and I'm provisioning a Docker container into your system, then I would be able to access all the files under XYZ in your system. So the rule number one, when you try in your laptop, ensure that after your work is done, shut down your Docker daemon. So this is a security best practice I'm letting you know. And number two, if you have a firewall, ensure that your port 2375 is blocked for the outside public. So this is the advice I would be letting you know, because I would be able to show you there is a database in internet. So guys, don't try it. It might end up you in some place. So there is a database called Shodan. Uh, Shodan DB. Okay, Shodan IO. Okay, so here and search Docker. This is a real vulnerability I'm showing you. You can see here. So you can see here. Yeah, it would ask me to log in. So here you would be able to find the IP addresses which have Docker daemon running. So you can see 4,637 services are exposed to the internet. So this is a database where you would be able to find it. You can get the IP address here from this database. And from your local, you would be able to connect to their Docker daemon, which is running in their local. It could be an exploit for an organization. It could be an exploit for your company. And even it could end up losing your data if you run it in your laptop. So do not try this unless you are a certified ethical hacker, because it might end up you in some place. So do not try it, guys. I'm letting you know to safeguard your data. Okay, so try to put a firewall, or once you're done with your Docker stuff, shut down your Docker daemon. So that's what my advice would be. Okay, so you have a lot of Docker things, and you have built 100 applications as a Docker container. How I'm going to manage it? So that's the next question that comes. Ask the people who have built the Docker daemon, again, the Docker containers, the Google. So Google built an orchestration tool called Kubernetes. So Kubernetes is primarily an orchestration tool that manages your Docker containers. So why we need to manage the Docker containers? The question is, the containers might get terminated, or uh, or something like it might get crashed. So we need to have some task master who is able to start the Docker containers when they get crashed, or when they get corrupted, or when they fail to start. We have to be notified. So there needs to be some task master. So Kubernetes does that for you, actually. So that's where Kubernetes came into picture. And when you try to run a lot of container apps, so the port mapping you need to do. So internally, when you run a container in your host, you need to map that to a particular port in your host. So the mapping you cannot remember. So for 10 containers, you can remember. Like I could say that 8081 to 8080, 8090. So that's a port I'm using for 10 containers. Think of 100. Think of 1000. Think of 1 lakh. You would not be able to remember all the container port mappings. So that's where you need something that would be able to orchestrate it. That's what Kubernetes is. So Kubernetes is a platform where you can orchestrate your applications as a containers. So just deploy your application and forget about it. If it gets crashed, or if it's going to have some issue, or port mapping, or storage, or whatever it is, whatever you want to do with containers, just configure that in the Kubernetes, deploy it, and forget it. It would be able to handle. Kubernetes would be able to handle it. The next biggest speciality about Kubernetes, it has the capability to scale. So when you run your app in a physical server or as a virtual machine, if you want to scale it, you have to add additional servers or additional hardware. That's how you would be able to scale it. Whereas Kubernetes, you would be able to add multiple containers. Okay, so that is the speciality about the Kubernetes. And adding a container will happen in a fly. So just think, you want to scale your infrastructure, or you want to scale your web server, because there is a huge traffic coming in. So let's take a live example, like you are visiting Flipkart and there is a big billion sale, and you estimate that 12 p.m. in the night today, so 12 a.m. in the night today, we can expect like 10 lakh customer traffic to the server. So what you would do in a legacy world, you will purchase a hardware, you will install the server, add multiple servers to it. So that's how you do it. But in the virtual machines, you will provision virtual machines like 10, 15 virtual machines, and you will add them under a load balancer. Then you will try to address the traffic. Whereas in the Kubernetes, you can just schedule, say that just before 12 a.m. in the night, scale the number of containers to 1,000. Immediately, it will happen in just a minute. You need not wait before 12 a.m. I have to do everything. I have to test it. Okay, it takes the traffic, everything. I need not do that. So Kubernetes does the orchestration. So again, Kubernetes is out of today's topic actually. So I'm not covering or deep diving those topics. So using this advantages of Kubernetes and Docker, how we are going to empower the developers. So that is the today's topic. So we'll move on to we'll actually move on to what we are going to see today. I'll show you with the demos. So what we are going to see today. So we are going to see three things. These are the three tools, each in their sequence for the developers. The first tool is called as JIB, JIB. So what it's basically going to do. So I'm not sure if the people in this forum knows about this tool sets or not. So I just want to reiterate. So this tools actually came up in the mid of 2018. So I presented these tools, like I said, the 5 years of Kubernetes in the Chennai Meetup Forum last year on all these three tools with a demo. So I want to reiterate that because the adoption of this tool still people are not that much good in adopting. So concept behind this is highly technical. So that's the reason they are not adopting it. So again, I want to advocate how to use these tools in the developers world. So to use these tools, a developer who has zero knowledge on containers and Docker and Kubernetes, these three tools empowers the developer. So you need not be an expert in Docker. You need not be an a master in Kubernetes. Simply use these three tools. You would be using Kubernetes and Docker internally. So if your company already has a Kubernetes cluster, and you can easily leverage these tools. The first tool that we are going to see is JIB. So what is exactly JIB? So let's see here. So JIB is nothing but a tool which was again built by Google. So one good thing that I like about Google is whenever Google builds a tool, they think everyone as a developer. So developers are the key in the entire IT infrastructure. That's what I would say. Even though I am a Linux system admin, I would say that the honor always goes to the developers because they are the one who writes the code and they delivers it to the customer. So Google always thinks developers are the key and empowering them is the best solution. And like I said in the DevOps, CI and CD, the code that developer builds has to be built at the end of CI pipeline. So it has to be delivered as an artifact. So the JIB tool actually action. So what it's going to do is when developer is building their Java code, especially this JIB is for Java applications, build or you can do a Gradle build. So today I would be showing a Maven build actually. When you do a build, you don't know what is a Docker container or you don't know what needs to be done. You need not have a Docker installed in your local. You need not write Docker file. So I didn't say about what a Docker file is. Docker file is something you need to write some that not a code, some steps to build your Docker container. Okay, so in the Docker file, you will write something, the steps to build your Docker images. With that image, you would execute to get the Docker containers. So that's a process. So you can learn more about that in the docker.com. This is a process again. So to build the Docker file, you need to have some knowledge. And as a developer, someone would say that I'm a Java developer. I have 10 plus years of experience. Why I need to learn this thing? Google saw, okay, let's not put the burden on the developer's head. Let's do something interesting where developers need not do anything, or let the developers need not get their hands dirty in the Docker, building something, end up something somewhere. So that's where they came Zip. So Zip actually produces usable or portable container image at the end of your Maven build or your Gradle build. So that's what it did. No need to create a Docker file. No need to have Docker installed. Any fancy stuff on the Docker. No need to do anything. It's a simple thing. Include this Zip in your build. That's it. It's going to pack your jar that is coming out into your Docker image. And if you wanted to push it to your Artifactory, so Artifactory is a place where you basically store your Docker images. So Docker images cannot be lying in your local. So it has to store somewhere so that it can be deployed. Like your jar. You have to give it to someone from or put in some place from where the op engineer picks and deploys into the production. So like that, you build a Docker image out of this build that has to be stored somewhere. It can be an Artifactory or it can be a repository. So Docker Hub is one place where you can do it. So let me show that place also. So hub.docker. So this is a place where you could store the Docker images, basically. So whatever comes here, whatever I build, like I build a Docker image, I have to push it here. If you are not part of any organization. If your organization has Artifactory and other tools, Nexus Repo or something, so Artifactory is a generic term. You have a lot of tools under Artifactory. So JFrog is one popular vendor. So like that, you have a lot of people. So they do support Docker registries. Registries is a place where you basically store the images. So I build a Docker image. I have to push the image to here. I have to see that its checksum are good, everything. Developer to do type these things in the console, they will not be doing it. So that's what this Zip is going to do in automated fashion for you. So this Zip is going to pack your jar inside a Docker image. It is going to push it to the Docker registry or a Docker hub or to your Artifactory, wherever you say. Ensure that it is up to date. That's what it's going to do. So whenever you build a Docker image, you need to build upon a base image. You need to mention a base image on which you are going to put your jar. So when I say a base image, you need to again learn more on the docker.com. So what is the base image and what is the use of it? So base image is nothing but the skeleton of your application. So when you say you need a runtime as Java, then you need to build that skeleton. That's what the base image is. You can pull a lot of base images that is already available in the docker.com. So using that skeleton image, it's going to pack your jar. You're going to push it to the registry where you're going to say. That's it. No need to run the command like docker build. Docker build is the command to build your Docker image. Docker push is the command to push your image. Before pushing, if there is a credential that you need to log in, then you need to do a Docker login command. So 3 steps. So Maven build you would be doing. Then you get a jar, copy that jar into your Docker file. That is the second step. Build your Docker image. That is the third step. Push the Docker image or log in into your registry. That is the fourth step. Fifth step is pushing that image to your Docker registry. That is 5 steps. 5 steps are involved for a normal developer if they don't use this Zip. This Zip into their POM file or into their Maven build. Do everything, whatever I said, the 5 steps, they would be able to do that in a single command. That is nothing but Maven clean build, Maven clean install. So that's command. That's it. Everything happens in the backend for you. What is the advantage of this Zip? So that's the question a developer asked me in the last session I presented. So Zip actually what it's going to do is it's going to create your jar. So when you basically a Java developer, might be there are a lot of Java developers in the forum. When you build a Java application, the jar would be created as a single entity. That means a single layered jar. It is not going to be layered. Whereas if you incorporate Jib into the model build, your jar is going to be layered. That means there's going to be some base layer, over that some another layer, over that layer 2, over that layer 3. Like that, it's going to layer, it's going to build layers for your Java jar. So if you're going to change something, for example, I'm changing something in the code, and Jib detects that it is the change only layer number 7, then Jib is going to build in such a way that only layer 7 is rebuilt, not the entire jar. Jib does in the backend. Okay, so it primarily, like I said, it produces a portable container images. And another advantage of Jib is it basically separates your Java application into multiple layers for incremental build. So Jib actually does an incremental build for your application. So whatever 3 tools I said, so this is the first tool that you need to learn. Jib is just a single line that you are going to add it in your POM. So what we'll do is, so with this said, so let's see something in live. So that is good actually. Everything. So keep on learning the theory part, and without seeing a demo, it won't be good. So let's get into the demo. Okay, so I will get into the folder tools and I'll clear. So I'll get into Jib. Jib is the folder where I have a piece of code. So I'll open Visual Studio Code and I'll get into Jib. All right, so this is a typical Docker file. So if you want to see what is a Docker file, this is a typical Docker file. So this is a base image, Java 8-JDK Alpine. So I'm not going deep dive into it. So this is a base image, and I'm copying my jar into it. I'm saying this is the location, this is the port my jar is going to listen, and this is the entry point. This is how I'm going to run my app. So this is what the Docker file would contain. So this is a step again a developer has to do. But whereas if you use Jib, you need not do everything whatever is here. So all right, so let me get into the Jib directory. And this is a typical source code. It's going to say hello world. So I'm not a Java developer, so I don't know anything about that. So the thing which I am interested is in POM, a typical Spring application. So here, so let's come to the plugins. In the plugins section, I'm going to add Jib. Jib is a Maven. Since it's a Maven build I'm going to do, I'm adding a Maven plugin. If you're doing a Gradle build, you can add a Gradle plugin into it. So just add the version. It's again a Google tool. Jib is a Google tool. So add these 3 lines. And if you want to push your images automatically into a registry, the Docker registry. So I have my own registry called Silver Spring. Inside that, I'm going to push this build as a container for developers. Okay. So if I wanted to do this in an automated way, then this is what it is. So just see, this is the line of code I'm going to add. This is the line of code I'm going to add into where it is. So here, the plugin. So this much is the line of code I'm going to add. Typical Java developers adding a plugin is a normal thing. And from an ops perspective or an infrastructure perspective, I would be giving this. This is the registry. You try to push it there. We will try to automate it from there. That's what an ops person would be telling you. So just 4 to 5 lines of code you are adding. Now you're going to see what it's going to do. So let's go to the console. So this is the POM file. So source code you can leave. Source code is of your choice. You can build whatever it is. So the POM is the place that is interested for the Jib. So just add this thing. Now go to the console. Now what I'm going to do is I'm going to give Maven compile, and I'm going to type Jib, and I'm going to say build. Because the build is done by Jib, not by the Maven. So Maven is a runtime out here. Java is the actual runtime. Over that Maven comes, over that Jib comes. So what's the advantage? When Jib does the build, it's going to do an incremental build. It's going to layer your jar. So let me hit enter. It is doing the build. And you can see here. So it is creating a layered jar for me. And you can see here, it has pushed to my registry. So it has set everything automatically for me. So let's go to the registry and see whether it has pushed or not. So that's what the check would be. So I have already pulled the dependencies. That's why it is not showing you. Because to save the time, I just pulled the dependencies and kept in M2 repository. So what it actually does, so the build happened here. So this is the place that build happened. Anyway, the source code, I have pulled it from internet because like I said, I'm not a Java developer. I used a hello world example from some GitHub project, and I added this zip over that. So here the build happened actually, and here your your packing of your jar into your Docker image happened, and this is the place it pushed into the registry, whatever I said. So did I do anything like, did I run Docker build, did I run Docker login, or did I do anything like Docker push or something? Automatically it has done everything for me. So this is what basically zip does that for you. If I'm going to change code, so even if I change hello world to the next event of Google. So the next event actually happens in a bigger way, right? So Google Next. So in that they spoke about this. There is a talk on this. It is a really an interesting informational video that you will be able to get it. This distroless image. So you have a lot of images in the Docker Hub. So let's go to Docker Hub and see. I want to have MySQL. So let's take MySQL. So you get a MySQL image. So this is an image. It is built upon, it could have been built upon a Red Hat operating system or CentOS or Ubuntu or whatever it is. So it basically has a shell, or it basically has a shell to log in. Your Docker image will be having a shell when it is executed. Whereas this distroless images, this distroless doesn't have a shell. So keep in mind, guys. So one thing I wanted to say again, if you learn hacking, or if you learn security things, or if you learn Linux stuff, the first thing first, what they try to say is always limit the packages that you put in the server. That is the first thing they will tell you, because a lot of packages you put, lot of vulnerabilities it will come up. So too much of anything is not good. So that's what they try to say. If you put too much of thing, it will attract vulnerabilities, or it becomes the attack vector for the hackers or someone to get into your system. Always put whatever you want. Don't put unwanted stuff into your server. So that's a security thing I wanted to let you know. So this distroless images doesn't have a shell at all. So what is the importance of shell? So now I'm giving PWD. So this is my laptop and this is the place. This is a shell. I'm interacting with my Mac OS. The interaction happens using a shell. Think of an operating system that doesn't have a shell at all. Shell is the first place where the attack vectors are injected, or that is a place where anyone would try to gain access. So Google has built a explicit image. This is again a distroless images are built by Google. And they say that they have been running this for 10 years in their infrastructure. So it is tried, proven, and it is security cleared images. So you deploy your app into this crystalless image, run security assessment over it. None of the tool will report any vulnerabilities in about the container image or anything like that. That's the advantage of it because it doesn't have a shell at all. It doesn't have anything. It just have the runtime packed into your OS. So when there is no shell, you cannot do anything. Just use this image, copy your jar, that's it. Say the entry point, close it. You cannot do anything more than that. You cannot add user. You cannot add any, you cannot create folders. You cannot copy files, like moving one file from one location to another location in the Docker image itself. You cannot do that. Only thing that is permitted is copy your jar into this baseless image, create an entry point. That's it. 2 lines of command in your Docker file. That's what this distilless image provides.
Nana Kerchief won't come to you.
I'm sorry. So if you're not in mute, can you please go on mute? So I hear a lot of noise from the background. Okay, so that is the advantage of this distilless image. So again, that is out of today's topic, but so I would just wanted to touch base that. So this is the advantage of zip. So let's quickly get into the other things. So any doubts on this thing, you can put it in the chat. So once we are done with other tools, other 2 tools, we would get will answer those questions. So the next tool is Scaffold. So Scaffold is another thing. Think like you have a local development environment in the place. Like you have a Visual Studio Code, you have Visual Studio IDE, or you have IntelliJ IDEA, whatever it is. So you have a lot of things in the place. You do the coding. You wanted to deploy in a development server. So infra people or ops people would give you a separate box like, this is the box, take it. This is the development box. Deploy here, test it for your own purpose. Play around with it. As a developer, you might not have much knowledge on how things work in a server. So how to deploy the code, how to run it, you may not know it. You try to run it in your local Java-jar, you give the jar name, that's it. So how to do that in the server? You might not know it. So how to do that in a Kubernetes-based environment? Again, you need to learn Kubernetes, Docker, all those things. So what if you have a Kubernetes environment, Docker, everything in place, but developers don't have that knowledge about the containers, how to leverage that? Scaffold comes for a rescue. So it is just a small utility, again built by Google. So like I said, Google builds tool thinking everyone as a developer. It's again a Google powered tool. What it's going to primarily do is it's going to containerize your app. If it is going to be a Java application, it is going to containerize your app using Jib, and it is going to release or deploy that app into a Kubernetes cluster, and it is going to refactor. If something you change in the code, it is going to immediately push that change into your Kubernetes environment or to your deployment. You'll be able to see that in a live screen. So you change something like hello world to hello to world. Immediately the change would be deployed into your dev environment without your intervention. That's what Scaffold is going to do. Basically, it simplifies the process of build, deploy, refactor, and repeat. This is what the development cycle is. So you build a code, you deploy it, you find something, refactor it, then you deploy it again. So it is a repeated process that involves some quantity of time. So Scaffold does that seamlessly for you when you try to adopt it in your environment. So let's see how Scaffold actually works. So before that, I want to bring up the Kubernetes platform into my laptop. So what I would do is Minikube, start, CPUs, I would say 2, and memory as 4096. Okay, so let the Minikube come up. So this is a single node Kubernetes cluster. So you can try it in your local. So dig about Minikube, dig about Docker, dig about Helm charts, dig about Tiller. So you have a lot of terms. So when you start learning Docker, you will start hearing a lot of terms about it. So I'm just creating a Kubernetes cluster inside my laptop. So it's just going to take a minute. So inside that, I'm going to build my developer environment. That developer environment is going to follow this principle of build, deploy, refactor, and repeat. So everything is going to happen in a cycle. So until this thing comes up, so I would explain you in the code. So Jib is over, so I will close that. The next thing is, this is my sample app. This is my sample app. And this is the POM I'm interested in again. Okay, so I'm again giving the Jib plugin, and I'm giving the image name, like I said. So whatever it is, so I'm just giving it. So it is a Java build again. Java Spring Boot based application. I'm just building it. What it's going to say is, it's going to say hello world. That's it. So nothing fancy stuff more than that. So let's go here. So the hello world controller, it says hello to Scaffold. Okay, so this is what it is. So now we are going to deploy this application into Kubernetes. Now you don't know anything about Kubernetes. You don't know anything about Docker. This is the source code you have. Now I'm going to give a command that's going to seamlessly deploy this app into Kubernetes with zero knowledge. Okay, so let's get started. Let's see if Minikube is up and running. Okay, so let's see kubectl get nodes. So this is a single node cluster, Kubernetes cluster. It is up and running now. So now what I'm going to do is I'm switching over to my app, my sample app. So I'm clearing it. So this is the folder I have. Whatever you see here, ls and k8s, you need not know about it. So this is something you need to know if you do it manually. When you use Scaffold, you need not know about it. Scaffold.yaml is something that would be generated automatically for you. So no need to worry about it. So what I'm going to do is I'm going to move that scaffold.yaml to scaffold.old. So this is the config file. This is the config file that you need to generate. So how to generate? So this is the app. Now I'm going to let you know, install Scaffold binary into your development environment. Now run the command scaffold. Say init. I'm initializing it. Give the build as Jib. Enable Jib init. So this is the command. Because it is a Java, I'm enabling a Jib build. If it is not a Java application, you can simply discard Scaffold init. So I'm going to initialize it. So it's going to take a couple of minutes. So until it creates the Scaffold file. Okay, so it has created. So let me say yes. Now everything is ready. Now you are going to see the magic here. So what I'm going to do is I'm going to run Scaffold. I'm going to run the Scaffold in dev environment. So the first step is download the Scaffold binary into your local. Initialize the Scaffold if you are using other languages. Initialize it with the Jib if you enable the Jib in your Java build. Next, run Scaffold dev. What Scaffold dev is going to do is it's going to deploy my application into the Kubernetes cluster. And what else it's going to do? Okay, so image, it is taking it from the local. Since the cluster is in local, it is picking the image from the local. So the build is happening, Jib build is happening for me. Docker image is being created automatically for me. And it's going to deploy into my cluster. You can see the Spring Boot is getting started. So where it is getting started? It is getting started in the Kubernetes environment. Okay, so now you can see DevEM is running 7.165 seconds. It started. So 6.27 seconds it has started. So let me go to new tab. And let me show you kubectl get pods. So just learn what these commands are. So you can see here, this is where my thing is running, 29 seconds. This is the pod that is running right now. This is where my application is running right now. So how to see the message that I have put it into my app? So for that, so there is a command, minikube IP. So this is IP address of my Kubernetes cluster. Now kubectl get service. This is basically a command, you need not worry about it. So you'll be getting an endpoint from your operational administrators. They will be giving a URL. This is a URL, use this thing, like that they will be giving. Since the cluster is in my local, I am picking up the IP. So this is a port in which my app is right now running. This is a port in which, so you need to know what is a port and how it has been binded. So when you learn a lot in Docker, you'll be able to know it. So what I'm going to do is I'm going to curl. I'm going to curl. This is my IP of my cluster. One second. Let's see. Curl 10.211.55.7 colon E1496 and my controller is in hello. I'm going to hit it. See, hello to scaffold. And this is the daemon that you saw here. See. So this is the host. So this is the host. And this is the internal IP. And I got hello to scaffold. Now what I'm going to do is let it be here. Let this tab be here. Let's go here. So you can see there is a hit that came. So I was the one who hit that. Okay, now what I'm going to do is I'm going to clear the screen. Let it be like this. Now what I'm going to do is I'm going to this code. I'm going to the source part of it. Now you can see the scaffold file is automatically created. In the hello world, I'm going to change it to hello scaffold. This is a change. As a developer, I did the code. I deployed into Kubernetes environment without any knowledge of Kubernetes or Docker. Now, the repeat process. I'm changing something. Now, notice the thing. I have not saved it. Still, you can see here I have not saved it. And you can see here the screen is empty. Now, what I'm going to do is I'm going to press Control Mac S. It is saved. Now, see the build process happening in the backend. I just saved it. The changes are being pushed. It is a layered build happening by layered build that is happening by the zip. The changes are being pushed into the Docker image, and the image is being deployed into Kubernetes. I didn't do anything. I just pressed Control S. Okay, so now it is deployed. So let's go to another tab. I'm going to hit the same thing. Now see, it is hello scaffold. It is changed. So whenever I press Control S after doing code changes, it is going to immediately deploy into the Kubernetes cluster. So again, zero knowledge. So developers need not worry about what the platform is, how it is built or something like that. So this is the advantage of scaffold. So if I'm going to, so I want to quickly show you one more thing. So I know we are already top of the hour, but I would take another 5 to 10 minutes extra, would cover the JX tool, and we'll wrap it up. Okay. So now you see here, I am just hitting it enter fully. Now I'm not doing any change, but I'm pressing Mac S, which is save. I have done a save, but see for the things. It is not building and deploying. That means it is watching for changes. If there is a change, then the changes would be picked up, build would be done automatically, and it would be deployed. I have not done anything. It has not deployed. You can go and check here. So I can hit the URL. So it says hello scaffold again. I have not done anything. I just simply press Ctrl S. If there is a change that is detected in your source code, immediately Scaffold picks that change, builds that, deploys into your Kubernetes. So one side you can code, one side you can see the URL. Or you can evaluate or validate your microservice or your website. So this is the power of Scaffold. Again, go ahead and try out bigger projects out of these things. So I have advised or I have helped companies to build Scaffold into their environment. So it is actually a great tool for developers. They not worry about anything. Immediately it happens everything in a fly. So this is the advantage of it. Now you've seen the build until dev. Okay. So before that, I want to quickly show you one more thing. So how the Scaffold stuff, what are the commands it has? This is the thing. So again, I pulled it from internet from the Scaffold dev site. So dev is the command we used. It does the build automatically. It deploys. It streams the log to you in the console. It watches the file. If there is the change, it does the build, deploy, streams log. It watches for file changes. If there is something, it builds, deploy. If there is no file change, simply it watches. If you want to do a single build or single run, single deployment, just run Scaffold run. That's it. You don't want to push the changes periodically. You want to push once for all. Then run Scaffold run. This is one thing. And if you simply want to build, you don't want to deploy, just do Scaffold build. So this is the command. So whatever you saw in the backend, the live action that you saw, This is the schematic of it. So this is a Scaffold tool. You can have Kubernetes either in the local, like how I had. It can be a mini queue or whatever it is. You can have remote Kubernetes. It can be in Google Kubernetes engine, or you can have your on-prem Kubernetes, whatever it is. If you run Scaffold dev, then the build happens locally and the image is stored locally. If you do a remote build, the image build happens in a remote Kubernetes cluster, and the image is pushed into your Docker registry automatically, and it deploys into your Kubernetes cluster and sees for the log stream and sees for file changes. If nothing is done, it's going to watch for file changes. And another beautiful thing of Scaffold is, now see here. Let's go here. What I'm going to do is I'm going to press Control-C. It does the cleanup for me automatically. I need not go and do the resource cleanup in the Kubernetes cluster or anywhere. It automatically does everything for me. So this is about Scaffold. So I know we are already top of the hour. So I would take just 3 minutes or 4 minutes of your time, extra time, and I would say what JX is. So anyway, we are going to miss the demo on JX. So JX. So now we have seen the live actions of Zip. So zero knowledge, build Docker image. Scaffold, zero knowledge on Docker and Kubernetes, deploy to Kubernetes environment. Now think from the developer's perspective, how could I promote this deployment of the development stuff to production? So Jenkins is a very popular tool. It is automation server that you have. Every organization have Jenkins. Every organization, almost. So think in such a way. I have zero knowledge again. I don't want to build Jenkins pipeline. I don't want to build anything. I don't want to manage Docker file. I don't want to maintain Helm charts. I don't want to maintain deployment YAMLs. I don't want to understand what Kubernetes is. But I want to manage a Kubernetes environment and I want to do the deployment. The tool that comes to rescue is JX. It is nothing but Jenkins X. It is again powered by Cloud Native Foundation. So it's a top product in their portfolio. So try to build or try to leverage this product for your for your organization or something like that. So what it primarily provides is it helps you to do the continuous delivery or continuous deployment in the Kubernetes environment with zero knowledge about the platform. Or you could use Jenkins X for GitOps. So the developer does the commit. You saw the thing, right, in Scaffold. When they try to save the code or when they try to do a change, immediately it deploys to Kubernetes. Think in such a way. I am doing a PR, pull request, or I'm merging a code to a release branch. Immediately I want to do everything like code scan. I want to do a unit testing. I want to do functional testing. I want to do a smoke testing. I want to clear everything, automatically deploy into Kubernetes environment, which is in production. This is called GitOps. So GitOps is right now getting a lot of attraction in the organizations. So Jenkins X would be able to do that. So what is the advantage of Jenkins X is it automates your Kubernetes deployment in a seamless fashion, and it incorporates a lot of policies that you could be able to add into it. So that's the power of Jenkins X. Again, JX is a binary. So you can see it here. JX is a binary. So you have a lot of commands out here. Again, you can deploy it in Kubernetes. It is really simple, but it would take time. So unfortunately, we are already top of the hour. So I would suggest you just dig more into JX. Anyway, I would be sharing the documentation in the CodePlexus site. So you can refer that and you can set it up in your local. So what is the advantage? What it's going to do? So one pipeline that I want to explain about JX is, so when a code commit happens, or you're doing a PR request, pull request, or you are giving a merge request, so someone has to validate. Maybe a tech lead or maybe a dev admin has to evaluate it. Okay, the code is what we expected. So this is part of a development process. So we have to preview that in a preview environment. This preview concept came in GitOps. So the moment you give a PR request, what Jenkins X would do is it would create a seamless pipeline and it would create a disposable preview environment. So when I say disposable, that is created inside a Kubernetes cluster. So until your PR is approved, that disposable environment would be live. The moment the tech lead or the dev lead evaluates it, signs it off, the environment would be tiered off. So that's the advantage of it. And next, what it can do is it can provide you feedback. Like you have an issue in some issue tracking tool, like the popular issue tracking tool out in the market is Jira. So you create an issue. In that issue, you might have said that this is the PR that I have completed. So if someone closes, say that they evaluated the preview environment and they are giving a sign off, immediately JX would be able to comment out in the Jira that this is the preview environment URL. This is where we are expecting a sign off. Please click here, evaluate it. Once you give sign off, this PR ticket would be closed. So that much automation, it would be able to do it. This Jenkins X. So that is the advantage of it. So anyway, I'm not able to show a live demo on it. So you can set the Jenkins X in the local using Miniqueue. You can try it out with some source codes. The setup usually takes 10 to 15 minutes, and the deployment happens in 2 to 3 minutes. So this is the estimated time for Jenkins X deployment. And if you don't want to install, but you want to see something in live action, you can see that in GitLab CI/CD. So GitLab CI/CD is built upon Jenkins X. Again, Google has built GitLab CI/CD based on Jenkins X. Whatever process I said, GitOps process, is followed in GitLab CI/CD. You can leverage that. Sign up for GCP, Google Cloud Platform account. Integrate your free GitLab account into it. You'd be getting $200 credits for Kubernetes platform. Integrate the Kubernetes environment. Try the GitOps. It would be really interesting there. So you can expect. So developers without zero knowledge, build a Docker image. Developers without zero knowledge, they are able to deploy it into Kubernetes environment for development. Developers, again, with zero knowledge of Kubernetes, Docker, and other stuff, they are able to push the code till production. So everything is automated, and this is what the empowering of developers is. So we are actually unfortunate to see the demo of JX, but right now I will stop ahead with it, and I will take up any questions for next 1 or 2 minutes, and then I'll hand it over to the organizers. So let me see if there is any questions. Okay. Okay, so I don't see any much questions in the chat. So if you have any doubts, you can just put it on the chat, so I'll be able to answer it. So meanwhile, till you put questions.
So, hi Pradeep, my name is Pawan. I put a question there. See, basically, I'm working on a Windows machine, my laptop, and it's a home edition, so as to say Windows 10 Home. So if I try to install Docker, I got to know that Pro or Enterprise of Windows 10 are actually what's supported. So how do I go about it? I mean, do you suggest any other options of working with Docker?
Okay, so Pawan, thanks for the question. So if you use Windows 10 Home, you would not be having an opportunity to directly install Docker into it, because in Windows, Docker doesn't run natively. So you need to have Hyper-V in the place. And Hyper-V is not part of Windows Home Edition. So that is one thing.
Okay.
So the options would be is you need to install a Linux in a virtual machine. It can be a virtual box, which is free and open source. Or you can try VMware Player, which is free actually for non-commercial use. You can try out with Ubuntu, or you can try out with CentOS. In that, you would be able to practice Docker.
Okay.
So that is a chance you have if you are in Windows Home Edition. Or else if you are ready to give up the entire Windows OS, then you can install any Linux operating systems like Ubuntu. So I would suggest just go ahead with VirtualBox. Over that, put your Linux VM into it, and then just practice Docker. That's what I would suggest.
Okay. So I have one more question. So assume that I'm working with a typical application which has, say, a backend followed by, say, a messaging queue and then a database. So Is it like I will be having a Docker container for each of these components?
Yeah, again, so for database, you would be running your whatever database you are having. So like Postgre or MySQL, you would be running as a container. For messaging queues, like you use Kafka or whatever it is. So again, you would be deploying that as a container. So everything would be as a container. So, but in the Kubernetes world, if you look into it, so the pods, so we call Docker containers running inside Kubernetes as pods. So they are not actually static. So they come up, they go out. So their lifetime is very short. So they keep on moving across hosts, and they scale up, scale down. So that's where Kubernetes orchestrates. So you need to have a storage binded to your Docker containers. So preferably, so more, as a suggestion, running database inside Kubernetes is not advisable. So that's what most of the people would let you know, because you cannot scale databases like how you scale web server or how you scale app servers. Because if you scale it, end of the day, the data corruption would happen. So it is not advisable to deploy databases into Kubernetes. Even if you deploy, you are going to run as a single instance. So there is no performance gain or something that you are going to gain out of Kubernetes. So that is one thing. But there are other databases like the Google's Cloud Spanner or CockroachDB. So those can scale based on your requirement. But again, what I would suggest is those are very complicated databases. So setting them up is very difficult. So what I would suggest is wherever you want to store data or wherever you want to maintain your state. When I say state, you want to store something in the disk and retrieve that for the consecutive sessions. Try to have a shared storage attached to your Docker containers. If not, do not deploy them in the Kubernetes. That's what the advice would be. So databases are not best candidates for Kubernetes. Web app and, like you said, messaging queues, they will go ahead with Kubernetes deployments.
Okay, thank you.
Yep. Okay. Mm-hmm. Okay. Yep.
Yes.
So this is our chat room, and on the left we have different rooms for different technologies, web dev, mobile dev, cloud native. Uh, Hello. Can you guys hear me? Can you guys hear me?
Yes.
I seem to have lost the connection. Just give me a second. You should be able to start seeing my screen, Abhi. Is it visible? So this is our chat room. You can join the chat room by going to chat.codaplex.org, and we have all these different channels for different technologies. We have a channel for jobs, posting jobs as well, and upcoming events. And we'll be posting our future meetups and sessions here as well. And besides this, I also wanted to share our crowdfunding campaign. So if you go to donate.codaplex.org, you should see our crowdfunding campaign. We launched this a few weeks ago, I think